Dear students, we are discussing about the solution of partial differential equations. We have already learned one method called the solution of partial differential equations by direct integration. So in this module, you have to study 4 different methods for solving partial differential equation. First one is solution of PDE by direct integration, which I have already studied. Then there are 3 more methods. First one is second one is Lagrange's method, third one is Charpit's method, and fourth one is method of separation of variables. Okay. Now today we will discuss about the Lagrange's method. Now Lagrange's method is applicable to only a particular type of partial differential equation called Lagrange's linear equation. So let's have a look on the definition of Lagrange's linear equation. So definition of Lagrange's linear equation is the partial differential equation of the form capital P small p plus capital Q small q is equal to R, where capital P, Q and R are functions of x, y and z. So this kind of partial differential equation is called Lagrange's linear equation. So a partial differential equation of the form P plus Q is equal to R, where P, Q and R are functions of x, y and z. Okay. Now next we will see how can we solve the Lagrange's linear equation, the steps for solving Lagrange's linear equation. So first step is you have to form a set of equations called subsidiary or characteristic equations using the formula dx by capital P is equal to dy by capital Q is equal to dez by R. So this is called subsidiary equations for Lagrange's linear equation. So look at the equation. Here capital P is the coefficient of small letter p and capital Q is the coefficient of small letter q and R, the right hand side, dz by R. Step 2. Find two independent solutions u of xy z is equal to a constant, say a, and v of xy z is equal to a constant, say b. It may be C1 or C2. So find two independent solutions u of xy z is equal to a and v of xy z is equal to b by solving the subsidiary equations where a and b are constants. So you can use the notation C1 or C2 also. Now here I taught one term independent solutions. Now here independent means one is not a function of the other. That means u cannot be a function of v or v cannot be a function of u. You have to get two independent solutions. Okay, suppose if you get the answer as u is equal to xy, u is equal to xy and v is equal to xy whole square. That means x square y square. So in that case we can write v is equal to function of u, which is equal to u square. So if u is equal to xy and v is equal to x square y square, then we cannot say that they are independent, since we can represent one as a multiple of the other or one as a function of the other. So here independent means one is not a function of the other. So that way you have to form the solution. We will see how can we solve the subsidiary equations, or how can we find u and v in detail, using in detail. So okay, now step 3, if you get the solutions as u and v, then our general solution to the partial differential equation is u is equal to function of v or v is equal to function of u, or another form is f of u comma v is equal to 0. We usually write in this way, f of u comma v is equal to 0, where capital F and small f are arbitrary functions. Now all these representations are equivalent. All these representations are same. So we usually, in the case of Lagrange's equation, we usually write f of uv is equal to 0. Or this is also possible, u is equal to f of v or v equal to f of u. So then we can, okay, I will make clear this idea using some examples. Now for writing the general solution of Lagrange's linear equation, we have to find u and v. That means the solution of the subsidiary equations. Now here we will discuss two different methods for solving the subsidiary equation. So that's an important part in the solution of Lagrange's equation. Now first one is method of grouping and second one is method of multiplier. So in this video we will discuss about the method of grouping. Now method of grouping. Consider the subsidiary equations dx by p is equal to dy by q is equal to dz by r. For example, if our equation is xp plus yq is equal to z, then we can form the subsidiary equation as dx by x is equal to dy by y is equal to dz by z. So first you have to write the subsidiary equations. Now take any two members, say first two or last two or first and last members. That means if we consider any two ratios from the subsidiary equations. Now let's consider the first two ratios, that is dx by p is equal to dy by q. Now if p and q contain z, that means here we have wrote dx by p is equal to dy by q. So if p and q contain z other than this x and y, try to eliminate it. Now direct integration gives u of xy is equal to a. Similarly, take another two ratios or another two members, dy by q is equal to dz by r. If q and r contain x other than y and z, try to eliminate it. Now direct integration gives v of xy is equal to b. Therefore, the solution of the given Lagrange's equation is phi of u comma v is equal to 0. Now this idea will be clear if we consider some examples. So let us understand this idea by using some examples. So let's consider the first question. Solve p tan x plus q tan y is equal to tan z. So comparing with the general formula, p plus q is equal to r, we can write capital P is equal to tan x, q is equal to tan y and r is equal to tan z. So the first step is you have to form the subsidiary equations. So subsidiary equations are formed by dx by capital P is equal to dy by capital Q is equal to dz by capital letter R. That is dx by tan x is equal to dy divided by tan y is equal to dz by tan z. So 1 by tan x is same as cot x. So cot x dx is equal to cot y dy plus cot z dz. Next we have to find the solution of this auxiliary equations or the subsidiary equations. Now here we are applying the method of grouping. So that is possible since if you look at the ratios, if you consider the first two ratios, cot x dx is equal to cot y dy. It does not contain the variable z. Okay, so first we can consider the first two ratios. So consider the first two ratios, we get cot x dx is equal to cot y dy. So this is in the variable separated form. So all the terms containing x in one side and all the terms containing y in the other side. So here we can apply direct integration. So integrating on both sides we get integral of cot x dx. What is integral of cot x dx? That is log sin x. So log sin x is equal to integral of cot y dy, integration with respect to y. So you get log sin y plus, here we have a constant of integration. We can choose the constant of integration as a. So instead of a is a constant, I am writing it as log c1. So I wrote here log c1 because if we write log here, we can simplify this expression to a more beautiful form. So that's why I take here log. If you are writing here a also, there is no problem. So for simplicity, I am writing here log c1. Now log sin x is equal to log sin y plus log c1. Now taking this log sin y to the left hand side, we get log sin x minus log sin y is equal to log c1. Now log a minus log b is log a by b. So you get log sin x divided by sin y is equal to log c1. So you can write, taking the exponential on both sides, you can write sin x by sin y is equal to c1. So first you have got a function of the form u of x, y, z is equal to a constant. So therefore we have u of x, y, z is equal to, what is c1? Sin x by sin y. Next we have to consider two fractions also. Consider the last two fractions. Cot y dy is equal to cot z dz. Now integrating, we get log sin y is equal to log sin z plus log c2. Now log sin y minus log sin z is equal to log c2. Log a minus log b is log a by b. So you get log sin y by sin z is equal to log c2. So sin y by sin z is equal to c2. So we can write, so we get another function which is equal to a constant. So let us choose this function as v of x, y, z. So we get v of x, y, z is equal to c2. That is v of x, y, z is equal to sin y by sin z. We put it as equation number 2. Thus we have got two independent solutions for our subsidiary equations, which are sin x by sin y and sin y by z. They are independent also. We cannot express one in terms of another. So from 1 and 2, the complete solution is function of u comma v is equal to 0 or phi of u comma v is equal to 0. So we can write phi of sin x by sin y comma sin y by sin z is equal to 0. So this is the solution of our given partial differential equation.